and real-time project exposure. The department is the, the department is led by Dr. M. Gomati Nayagam, HOD CSBS, Dr. S. Erna Veerappa Dinesh, Associate Professor CSBS, Ms. K. Usharani, Assistant Professor CSBS, Ms. B. Alni, Assistant Professor CSBS, Dr. M. Jayasundari, Assistant Professor CSBS, Mrs. M. Shabana Fatima, Assistant Professor CSBS, Ms. M. Preeti Ram, Assistant Professor CSBS, Mrs. Rekha M. Assistant Professor CSBS, and Mr. Ramakrishnan, Assistant Professor CSBS. We are glad to invite Mr. Dushyant Duberia, Cloud Computing Engineer at Amazon Web Series USA, as our guest speaker today. Now I invite Ms. Nitika Shri from third year CSBS to deliver the welcome address and introduction the speaker.
A very good evening to everyone present for this international webinar. It is my greatest honor to begin by welcoming our distinguished resource person and keynote speaker, Mr. Dushyant Dubaria, Cloud Computing Engineer at Amazon Web Service USA. We are privileged to have Mr. Dubaria to share his invaluable expertise and forward-thinking perspectives on enhanced cloud and virtualization for future innovators. His presence and insight will be the highlight of our event in inspiring the next generation of technology and leaders and innovators. Next, it is my pleasure to welcome our Chief Patron, Dr. L. Ganeshan, Principal, Ramka Institute of Technology, whose steadfast support makes this event possible. A warm welcome to our respected patron, Dr. S. Rajakarnagaran, Vice Principal, for his continuous encouragement and guidance. I am also pleased to welcome our convener, Dr. M. Gomati Nayagam, Head of the Department, Computer Science and Business System, whose tireless work and vision have been instrumental in organizing this webinar. Let us also extend a special welcome to Dr. C. Arunachala Perumal, Head of the Department, Electronic and Communication Engineering and IST Faculty Chairman, whose inspiration keeps the students' chapter active and thriving. I warmly welcome all the esteemed faculty members whose dedication to teaching and mentorship are at the heart of our academic community. Finally, a heartfelt welcome to all my dear students. Your enthusiasm and curiosity drive us forward and make every event meaningful. Let us make the most of this remarkable evening and learn together from our outstanding minds. Thank you, and once again, a warm welcome to all.
Thank you, Nitika Shri. Now let's hear from our esteemed speaker, Mr. Dushyant Dubaria. Sir, the session is yours now.
Hey, good evening all. Can you all see my screen?
Yes, sir.
Yeah. Thank you again, for the warm welcome. Nice meeting you all. Good evening, everybody. I am Dushyant Dubaria, one of the senior cloud engineer from AWS. So I work with the startup Gen AI team. I help the upcoming startup with their business need, so anything that they need, so that's where my role is. So again, I don't want to talk too much about myself, as this session is more about student who wants to get into general cloud computing, or want to learn more about the AWS services and cloud computing. So yeah, and before we get started with the agenda, I really want to thank you faculty members from the Ramco Institute of Technology for arranging this. Even thinking about the future cloud computing is even important. So they have a good vision. So thank you again, all the faculties that was working on creating this presentations and stuff. So let's get started. So today agenda is introduction about AWS. What are all the main pillars of AWS cloud? What services are provided by AWS? Like we will talk about briefly about the AWS infrastructure and services overview. if there are any advantages, what are all the advantages we will be discussing, and then at the end we will see what are all the different streams that you can go through and innovate with AWS. Now, main motive for this particular session is not to teach you any technical stuff about AWS or cloud computing. Main motivation of this particular session is to get you familiarized with the cloud computing technologies or create a roadmap on how to learn cloud computing. And because I work for the AWS, it is easy for me to explain the real world AWS technologies that customer and businesses use, so that you yourself can connect, uh, like how you can use those services. So again, in this particular session, if you don't understand anything, it is still okay. So again, the main motive is to give you a roadmap to learn the cloud computing. Doesn't matter, AWS, Azure, Google Cloud Platform, whatever cloud platform you choose. So the main motivation is to help you get started with the cloud computing. Is everybody clear?
Yes, sir.
Okay. Okay. So let's get started. So again, introduction to AWS. So everybody, we know AWS is a cloud provider. Does anybody know in general what is cloud, word computing, a platform? Does anybody have any idea what is it? Okay, so from this particular picture, on the left hand side, what you see is uh, what you see is these are the server, storage, database, application racks that you might have been typically seeing in the data centers. And there is a guy who is trying to access, and those servers can only be accessed through the network. But with the cloud, what cloud companies have done is they have moved all the server, storage, application layer into the cloud, which is in their own data centers, and they've been giving those services to the customer over the internet. So some of the technologies that you might have already studied with with the course curriculum is infrastructure as a service, platform as a service, software as a service, function as a service. So these are all the offerings any cloud provider gives to their customer. And now why we went into this particular direction is because of the scalable solution. And it's not just the network, compute, storage, in general, anything. So if you would like to go global with the services that you have or the websites that you are building, it's very easy as an engineer to go into cloud, spin up any virtual machine, test your logic, test your functionality, and if everything is working, you can immediately go global. So let's just go into the history on like or about the on premises. So from the bottom is where the network layer starts: storage, server, virtualization. There is an operating system, middleware, runtime, database, and application. So this all layers previously customer used to manage it by themselves. So if you see, you manage is what the blue piece is. But as the cloud got evolved, so things became like infrastructure as a code. Companies started saying, hey, don't worry about the networking, hard disks, servers. I will rent it for you. You take care of the operating system that needs to be installed on the servers and how to run your applications. Again, slowly it got evolved. Platform as a service. So there are a lot of offerings where entire platform has been given. You just come up with your application and the data and run that on AWS. And next one is the software as a service. So again, software as a service, you don't need to manage any of this stack. Everything AWS or cloud provider will manage it for you. You just use it. So some of the examples of the infrastructure as a service um, will be like cloud formation template, where you create the template to deploy the resources in the cloud. Platform as a service examples will be like Beanstalk, where all the stacks have been up and running with created. You just come up with the application. Software as a service examples will be like a storage service, like a Google Drive or any kind of those drive where there is an application. It's a software. You just use that particular software. You don't need to do anything on your side. So next, key pillars of AWS. This is the most important slide from the entire presentation. Now, why I say this is because most of the cloud courses that you might have taken on the YouTube or maybe on Udemy or edX, the main fundamental or main pillars of cloud are like four pillars. The Gen AI is the new one: networking, compute, storage, and security. Now, if any students who wants to learn cloud, they can break the entire cloud journey into this four pillar. So some engineers they like compute, which is virtualization. Some engineers they like databases. They like to play around with the databases. Some are very good with the securities. Some are good with network understanding. So if you are some of those student, first take one of the pillar, understand what it is, and slowly start gathering knowledge about the other pillars. So my core strength in AWS cloud is the compute piece. I really understand the compute piece of virtualization, containers, Kubernetes, all these services. I really understand it well, and that's where my core strength is. But I also have basic understanding of the networking, storages, and security. But again, as I said, so don't worry if you don't know the entire cloud. Break down your cloud journey by splitting it into five different pillars or particularly four different pillars, and choose whichever one you like. Gen AI services are now a new boom. So all the cloud providers they do have now started giving Gen AI services. So again, if you are a Gen AI or AI folks, so yeah, you can again take that particular pillar uh, and just get your hands dirty. Yeah. So again, this is the AWS core infrastructure and services. So as I was been previously talking about the pillars. So these are the main pillars where your strength or your knowledge are usually important. So if you are again a database engineer or you like working with the data, is where all the services or all the technologies that are out there, start learning those and you will be able to understand basics about the storages and the networking. If you are a compute guy who understand virtualization, so servers are your strength. Networking, then load balancing, virtual private network, routers, switches is where your core strengths will be. Again, securities covers firewalls, access control list, administrative of the user, deleting the user, security groups, and all of those stuff. Now, for any engineering, again, this is my experience. Maybe everybody might have a different experience. Anybody that is learning engineering, he needs to have two different knowledge. One is basic understanding of the networking fundamental, and the second is the foundation Linux system. If you understand this two, it doesn't matter which field you are in. You are in aerospace, computer science, software, whichever field. My personal experience is you will have a foundation ready. Now, why I say that? Networking fundamentals are like you are on your system or on your Windows machine. How do you connect to the internet? Like you have routers, you have switches, so you need understanding of those basic fundamental networking, because in the cloud or in any engineering, the actual stack starts with the network is where the uh, like how those servers are connected out to the world and how do you access it. So some of the networking fundamentals are the OSI models and the layer function. So from bottom to the top, what is the OSI layers? Like networking, application layers. So all those 7 layers that we have. So yeah, those understanding is very important. TCP IP, you need to understand what is an IP addresses, what are all the common ports. If somebody asks, talks about the HTTP, you should immediately be know it is a port 443. Again, basic understanding, you need to know about the uh, TCP IP protocols and the ports. Second is the IP addressing and the subnets. Again, you should be able to know if there is a bigger address range, what should be the subnet when you slice that particular network into small different networks. uh, Again, security basics is like firewall, what is an IP table rules, um, DNS architectures and resolution. Again, very important. So whenever you type anything on your browser, how do you connect to those particular servers? What happens under the hood? So those concepts again needs to be clear. Again, I'm not going to go too much deep into the foundations. I expect, as you are all like computer science students, if you know, great. If somebody is just starting their journey in the cloud, make sure you have this basic fundamentals. Again, YouTube videos are out there who has like 5-10 minutes. Go through those, just get a gist of what it is. And last thing is the network troubleshooting methodology. If something is down, you are not able to connect, how do you restart the network, how do you troubleshoot those things, is it's the foundation. Now let's get into the first pillar of the AWS cloud, which is the global infrastructure. So AWS, if you see the entire world, the dots are the regions, blue dots are the regions. So these are all the global infrastructure or the global network for the cloud. So why have like different why have a global network? First of all, let's just take a look at the official documentation. So yeah, so the word global infrastructure means, as now the world has been changing, anything that you create, it's not necessary that it will be in India or in Chennai or in anywhere. It has to be global. Anybody needs to be able to access your website or your software or whatever you create globally. So that's why AWS has created a global infrastructure where every region has small or big data centers where you can host your virtual machines, and that's how you can deploy your application. So some of the core concepts about this global infrastructure are the region. I will go to the next slide. What is a region? And within the region, there are availability zones, and within the availability zones, there are like presence of points, and there are local zones. So if anybody has a very high sensitive application that needs to be deployed very close to their region, usually cloud provider, they do have like local zones and wavelength zone where you can deploy it to the closest nearest data center so that you have the lowest latencies. Now let's just understand, break down the global infrastructure. How does under the hood it looks like? So if you are aware about the data center, they are typically houses of thousands of servers, and that data center is nothing but an availability zone, and that availability zone might have multiple data centers for fault isolations. So you can see one availability zone having multiple data center. Now what is an availability zone? So availability zone, consider this an example, a Singapore region. A Singapore region, what if there is a flood on the east part of the Singapore region or the west part of the Singapore? There's some issue with one of the region, maybe there's a natural calamities. So what they do is they split the entire region into different availability zone. So they call it as like 1A, 1B and 1C. They are geographically distinguish across the region. So they are so many far that if any natural calamity happens, most likely only one availability zone will be down. So far clear? Okay. And for the resource purpose, I can share the link. Again, so the main purpose is not to teach any of this, just to give you understanding about all of this. First word, if you don't understand, great, you can read through those documentation and get familiarize yourself slowly. Now again, this is these are still blocks. Let's understand even further down. So now you know what is a region. A region is nothing but a region. So Mumbai has its own region, or India has its own region. Singapore has it's a big region. So now within the region, there are availability zones. Availability zones, as you know, it's nothing but a data centers. What does the data center has? They have servers or racks of servers, and in one of those rack is where you create a virtual machine. So now this is where whatever you have learned about the virtual machine comes into picture. So can anybody tell what is a virtual machine? Any volunteers? Okay, let's see. Okay, so virtual machine, as the word suggests, is the virtually created machine. So consider an example. You have a host. Consider that host is nothing but your Windows system or your Mac system. Windows has its own operating system, which is Windows operating system. Now, do you want to test something on that particular Windows machine? Maybe install a Python or to do certain things, or run your Python script. How do you do that? Yeah, you can install the Python library on the Windows and do your testing. But another way of doing that will be to create a virtual machine on the host. So why would you create a virtual machines on the host? Now the scenarios will be, you need a different Python version, different Java version, or different type kind of software on your virtual on the Windows machine. You cannot install all of those things on a single virtual machine, because different application might require different versioning. So it's not, you won't be able to install different versions on the same host. So that's where the power of the virtual machines comes. Again, it creates a virtual layer on top of your hypervisor. Hypervisor is nothing but a small layer which helps you share the resources of your hardware. So if your Windows hardware has like 8 GB RAM or 16 GB RAM, with the hypervisor layer, the virtual machines can now access or share the main hardware that is available on the host. And who does that is the hypervisor. One of the simple hypervisor is called the virtual box, which you might have already heard about. Uh, yeah, somebody have question? Does anybody have question? I see Well Selvi raised his hand. Okay. So yeah, so with the hypervisor, one of the simple hypervisor that you might have already used is virtual machine. It helps you share the resources of your virtual machine with your actual hardware, which is your Windows machine or a Mac machine. So this is how it looks like. in your region there will be multiple availability zones. Within the availability zone there might be multiple data centers. Data center might have a big rack. Within that rack you will have your virtual machines. And as you see, the big white box is the US East one, which is the North Virginia region. Within the North Virginia region there is a small data center which is availability zone, whose name is 1A, and it's where your virtual machine is running. Okay, let's move on. So why create a global network? So again, security is one of the biggest reason. We want our customers or traffic uh, between the AWS region to traverse via the infrastructure. So that way, if customer have any issues with one of the region, they can always fall back to the other regions. Now, availability. So if tomorrow you want to scale or your business is scaling, you don't need to go buy the network rack or storage or hard disk and use it for your application. So availability is the biggest region because the data centers are across the um, geographical region. It's the high, availability is very high. Again, reliability and performance. So AWS owns the infrastructure, so they do the patching on your behalf of the rack, cooling systems and everything. It's what the cloud providers takes care. And the biggest advantage is the closer to your customer. So if if your applications are global services, so anybody from India who would like to access your application, so you will have a copy of that particular application within the India region, so that way they don't have to go to the Singapore or US or Europe. So global reach, and to have that particular application closest to your customer uh, is why the global networks are important. Now, let's just get into the crux of some of the AWS services that has this networking offering. So, one of these services, the virtual private cloud. Again, it's a private cloud just for you where you can deploy your servers, and those servers will have its own IP addresses, its own network topologies, routing, and security group rules. So, you can create as many virtual private cloud within your AWS account. Uh, yeah. Uh, Again, I expect everybody to know like what is routing and security groups. So I heard from the faculty that you are like third year student, so just expectation is basic network understanding if you have. So yeah, virtual private cloud is a private cloud where you can run your AWS services. uh, Now at the very high level, this is how the actual infrastructure will look like. So consider an example. If you have your on premises, maybe your home or maybe your actual office. So how do you connect those offices to the cloud? So again, bringing all the network services together is how you this looks like. But as you saw from the previous photos about the global network, so this is how the actual network will look like. Okay, so the next pillar is the compute pillar. Uh, Again, anybody understand what is a word a compute, or like computing or CPUs? Okay, I will continue. Okay, so again, in the previous slide, I was talking about the importance of networking. The second foundation is the systems or the Linux administration. So Linux is an open source operating system. So most of the companies, they use Linux because again it's an open source, so you don't have to pay for the licenses and all of those stuff. That's why it's a Linux is the most uh, familiarize operating system uh, in the actual businesses. So basic Linux architecture and distribution, more you need to know. Distribution, again, it's like Ubuntu, CentOS. Again, you need to familiarize about those operating systems that are out there. You need to understand the command line interface. So like an example, if you open a terminal, so this is a command line interface, so you should be able to know how to run some of the basic commands on the terminal. If you like to search certain things on the computer, usually in the Windows we go into the C drive on the right hand side, we search it. But in the real world where you have a very big servers, you cannot just run searches on the entire operating system. So you need to know some of the basic commands where you can run and look for some of the files that you are looking for. Another example will be you are troubleshooting something and you would like to see certain patterns within the text file or within the log file. So you need to know basic uh, I mean, system commands and like how to operate the system. Again, file system hierarchies, uh, how does the storage gets attached uh, to the Linux system or to your Windows system. How do you install packages within your system like apt, yum? So basic commands are yum install curl or whatever software you would like to install. You need to know how to install that on a Linux system. Process monitoring, again, very important. If you are troubleshooting something where you are seeing some sluggish behavior on your website or on your system, how do you troubleshoot those is very important. Like commands like top command will help you. Let me show you. So if you see, it's a simple command where it will tell you the average CPU utilization, which is 16 percentage, uh, the memory utilization. So you need to know basics of all of this thing, how to search through each column to understand what is the state of the process, how much CPU utilization it is using, what is the process ID, how to kill that particular process, and all of those stuff. Shell scripting, again, very important. In the real world, nobody will ask you to run 5 commands on 100 different servers. So basic for loop, while loop, or basic scripting knowledge, if you have, it's very bonus in real world, because now you can handle multiple different servers using those logic that you have. Now let's go back. Yeah, and let me, so I have a book that I refer you. Let me see if I can share that in this chat. I'm not sure if I can attach the file here. I will share with the faculty members. Probably he should be able to share those book with you. Very, very, very important. Again, I'm emphasizing this on this two foundation, which is networking and Linux, is because you don't see those servers on in front of you. So how do you access those servers? Once you have the access, what commands you run on those particular is very important. In real businesses, they have hundreds and thousands of servers, so you need to be able to manage them using command line or using some kind of automations. So yeah, I will share that particular book. Again, it's written in very simple language. You can create projects out of it. Very simple, maybe 100 page or 60, 70 page, I don't remember, but very easy to understand. So you will have your groundwork or foundation ready with that particular book. Again, now let's move on with the compute section. So again, in your curriculum, you might have used virtual machine containers. So one of the other one is this serverless. So now let's now understand the history of this. So again, bare metal is nothing to illustrate. Is like, consider your local machine. It has a server, it has an operating system, and you have apps running on it. That is not, no other things. Okay, so there's no other thing. It's a simple laptop or a servers that you see. Now, virtual machine is where you install the hypervisor layer. Example will be VirtualBox, and then you can create a virtual machine so that virtual machine can access the server hardware y- using that hypervisor. And now the advantages of that are, you can have different operating system running on that particular host. Example will be, you can have a Windows machine where you can run on top of it, you can run the Linux servers, and you can have multiple of those, as long as you have enough memory or CPU to share with those VMs. Now, the problem with this particular setup is, for each virtual machine has its own operating system. So if you just want to run some simple application, why do spin up an entire operating system to just run a simple application? That's where the next concept came about, the containerization. Containerization, again, deploy a simple container engine, and container is where you actually install all the dependencies and you can share the resources. So container engine is what helps you do that. Now, with the serverless technologies, you don't even need to build containers. Just create a simple Python functions, and AWS or any cloud provider will be able to run those functions for you. Again, functions can be, you want to do some calculations, or whenever uh, somebody uploads some files into some of your buckets, automatically you want certain actions to be performed. So serverless is where that logics comes in. It's just a function. You run it on cloud. So again, green is where you manage, and as we progress, there are different offerings with the cloud providers, which where the heavy lifting will be taken care by the cloud provider, and you just need to manage your applications. Again, different components of your application might require different services. So it's nothing is like important, not important. Everything is important. It's just different application will have a different advantages over using this offerings. Uh, Now let's talk shortly about the commercial example of infrastructure as a service. Again, EC2 instance is one of them. It's a virtual machine that is been offered by AWS. Container as a service is like a Fargate or Elastic Container Service, or Kubernetes is where you create a container and deploy it on AWS. And function or serverless as a service is where they called it as a Lambda. Again, it's just the name, but it's a serverless. So those offerings is where you can use it to run all this IAC, CA, and uh, function as a service. Again, now let's get into the crux of what AWS compute services are. Some of them are like Elastic Compute Service, load balancing, Elastic Container Services, and auto scaling. And these are some of the services that I have mentioned, which you might have already read it about. So yeah. So again, you might have seen most of the cloud providers, they say C5x large, C4x large, or like some of the instances. So again, basic understanding of this is, instance family is the first letter. C means those virtual machine is compute intensive. Like there might be an application where you require a lot of CPUs and not really a memory. So you choose instance family that has the most CPUs. So that's why, again, just based off this particular uh, annotation, you will be able to see, oh, this is a compute family or like CPU family with the generation of fourth and the size of the instance. So again, uh, you don't have to remember any of this. I'm just giving you illustration. Any cloud provider might have a different annotation, but just looking at it, you will now be able to know if somebody is writing M means it's a memory intensive virtual machine. So it might have more memory and little bit of less CPU. Somewhere you will see G type, which has like GPU instances. Now some instances they required heavy networking capabilities because there are a lot of traffic that is going in and out. So sometimes you will see CN type, N in the between. So you will now see, oh, this is a compute network with the fourth generation and the size is the large size. So similarly, you might see some instance type uh, which has um, like G5N, like G5DN, so G5. So now just looking at this, you will be able to understand, oh, this might have this. Again, you don't need to remember. I'm just giving you some understanding about how to look at this resources by just looking at the name. Again, uh, if you have understanding about the virtual machine, how to create them, there are different general purpose virtual machine. We can use it for general purposes. If you have CPU intensive, you can use CPU types. Memory intensive, if some virtual machines that require heavy IOPS, like a lot of writes that you do on those particular machines, or your application does that, then yeah, you need to know use storage optimized instances. And again, recently all of this GPU based are like G5, G or G6 instances, and AWS now have launched their own flavor of the virtual machine, which is the inferences and the Trainium instances, which is the TRN1 and all of those stuff. Okay, any questions so far?
No, sir.
Okay, okay, let's continue again with the compute thing. Uh, Again, load balancer is nothing but the word suggests it balances the load. So it's a layer where your client will connect to, and that particular tool or that particular software or whatever that service is, he should be able to balance the load across the virtual machines. So again, why we do that? Just an example, you have one virtual machine where you are running your application on, and tomorrow you see that a lot of people are using it, and you cannot have a load that can you cannot that machine cannot handle all the load. So you will create a two different virtual machine. So now you tomorrow you create 50, 500, 1,000. So you are not going to give the IP addresses to your client. So that's why you create a load balancer in front of it. You give the load balancer IP or the DNS name or the full FQDN to your customers, and that's how customers should be able to access the load balancer, and on the load balancer should be able to send the traffic to the backend virtual machine. Another advantage will be the security. You don't want anybody to directly access your application or the machine where it is running. You don't want anybody to even know where it is running. So that's why another example will be to have somebody in front of those servers for security purpose. Again, this is what the load balancer looks like. Auto scaling, again, as we said, tomorrow your business is scaling. You now have two different virtual machines, or like for 100 different virtual machines. Who manages those? So there is a service called auto scaling. So based on the metrics is like CPU, memory, what is the utilization? If the utilization of your CPU and memory is like 60, 70, 100%, you can add one instances or 20 instances. So those all uh, auto scaling group have the capabilities of adding the instances and removing the instances during night when nobody's using. So those things are automatically done by the auto scaling group. Again, so this is a load balancer. Load balancer uh, clients will connect to the load balancer, or load balancer is how will distribute the traffic to the instances. Now, just a short video, not video, but a GIF about. So if you see on the bottom is where the virtual machines are. It scaled up when there was a load, and automatically it is scaling down, and it's in between is where the load balancer is, so automatically it is load balancing the traffic. So again, a short video, not video but a gif. If you would like to learn more about this algorithms that are available, this is the link. If you want to learn more about auto scaling group, yeah. Okay, let's move on. So again, that was the compute part. Again, the word compute means the computation, where the actual horsepower is required to run certain things. So compute means CPU, memory, resources, all those GPUs or network layers. So those things are there in the compute piece. Now, storage is the third pillar. So you might have heard about Google Drive, maybe your hard disk, maybe SSDs, thumb drive. So what are all those storages? Does anybody knows what are all these storages called? Like example, what is a hard drive called in your storage? I mean, technically. Okay. Okay. Um, so yeah, so there are different type of storages. So block storage is what the hard drives network attached storages are called. The word block storage means data are stored on your hard drive in a block format. So that's why they say block storage. Now there's another one which is file storages. So it's unrelated data block managed by a file system. And some of the examples are like network attached storage, your NAS, or your Windows file servers, or NetApp, ONTAP. The third one is the object storage. Object storages examples are like Google Drive, S3 bucket, all of those things. So where objects are stored, like if you like to upload something to the Google Cloud, so those storages, they are called like object storages. There's another one which is called the database storages, which will cover it in the next slides. But these are some of the storages technically you need to remember. So whenever you talk about your local disks and stuff, try to use the word, oh, it's a block storage, it's been managed by your file systems, something like that. When you talk about the Google Drive and stuff, try to rephrase it in a way that it's an object storage where you upload the object or you manage the objects. Now, storage characteristics, mostly we know, like if you are creating your resume, mostly we know we need to have a versions of it. We usually say resume 1, 2, 3. But in the businesses, it's not just the versions or the size of the storage. It's about the durability, availability, security, cost, scalability, performance, and integrity. So again, during the interview or when you are studying, particularly on the storage section, try to cover all of this particular topic. So now, whenever you're even giving an example of Google Drive, you should be able to say technically the durability about your files, where those file stores are, what is the availability, what measures my availability of my files or my important data, how does the security is measured, what is the cost per GB for those. So when you will talk about those again during the interview, during your normal conversation, is where the crux of this storages are. So again, if you are an engineer who like talking about this scalability, security, and particularly on the data, so storage is your main pillar. So now let's move on with the actual again crux of the AWS services. So one of the oldest services is the Amazon S3. S3 word means three different as simple storage service. So again, it's a web accessible storage services. You can access it via the API or via an HTTPS, which is from the browser. It is highly durable. There are nine nines in this particular thing, which means there is like 0.00001% chances that your data will be lost. So this is their selling point, that this is by design, that they have designed it in a way like all these characteristics that you see it in your previous slides is all been covered by that. So security, performance, integrity, durability, availability, and all of those things. Again, it's a limitless scaling. It doesn't matter you have 1 terabyte of data or 1 GB of data or 2 MB of data. AWS or any cloud provider will automatically scale that particular backend to store those particular data. And important thing is you only pay for the demand that you are, like, if you are storing 5 MB data, you only pay for 5 MB. If you are storing it for like 100 GB data for 10 days, you only pay for 10 days. Like other providers, that's not how it works for them. They have some subscription, they charge it, but particularly with the S3, that's how it has been designed. They have multiple tiers to match your workload. Again, we will go over that in the next slide. Again, when you talk about the data, always remember the data lifecycle rules. So again, you have that data maybe in your own machine or on your Windows machine, you have thousands and thousands of files. How do you manage them? So the easiest way will be, how can you create a life cycle rule of your files? Like, okay, I don't want any data to be on my laptop if it is more than 1 year. And again, that is a very risky transaction. You don't want, which means it will automatically delete. What if you have a luxury to now move those files into a storage which is super cheap, but you can still access it? So those data lifecycle rules, again, the logic is that you create a lifecycle rules around your data. So whenever you don't want it, you delete it. If you want to archive it after certain days, if there is different versions of the data, so those lifecycle rules you can create it. Again, with this S3, you can also create static website hosting. If you have some simple website that you would like to host, you can put it in the S3 and you can access it via the CloudFront or the S3 global endpoints. Again, so audit capability, whenever somebody deletes the files, you can see who deleted it, who uploaded it, when it was been uploaded, when it was been modified. Again, pricing is another thing. Again, pricing is not important for this session, but again, there's a price. So it's 23 cents per GB. So this is where I was talking about the choice of the storage, different classes of storage. So standard is where the mostly but there are different tiering that you can take advantages of. Examples will be, again, if you don't want your data to be available across all the region or across the availability zone, you can just create it in one different AZ, which is the standard IA. If you have, you can use the intelligent tiering where you can move the data which are very less access or frequently access into cheap storage solution. So there are different tiering like instant retrieval. So if you like your data to be archived after certain days and you still want immediate retrieval, you can put it in the instant retrieval um, category. If you want flexibility that maybe I may need it or maybe I may not, if you are in that particular dilemma, you can also have it in the flexible retrieval. And when you know that for sure you don't need that particular data in real near future, but you still want to keep it maybe for security compliances, so you can put it in the deep archival. So whenever there is an audit or whenever security team asks, hey, show me this, you should be able to take a day or couple of days to pull all those data. So the advantages of all these cloud providers or these services are, you can use this intelligent tiering for your businesses. Whereas uh, Google Drive and all of this, they don't provide this because that is at the personal level. But at the business level, you need some intelligent tiering or life cycle around your data. So yeah, again, you can use this intelligent tiering. Uh, Again, S3 management features. Again, you can organize your file. So each file can have their own tag, prefixes, versioning. So again, the basic example will be resume building. Whenever you create a resume, you keep adding different files like V1, V2, this date, that date. So in businesses, it doesn't work like that. You cannot do that. So you can have a file with the same name, but AWS will create a different versions for you under the hood. Let's see if I can show you that. So again, this is the console of AWS. So again, so this is a simple bash script that I have. So if you see, these are the different versions. So AWS does this for you on the fly whenever you upload the file with the same name. So there will be different versions that will be created under the hood. So if you accidentally upload something that wasn't good, you can go back, take a look at the different versions, click on it, and then download. Again, you can do all of these things via your program also, but I'm just showing you on the cloud. Anyways, let's move on. So yeah, again, monitoring, very essential in business. You need to exactly know who modified your file, when they modified, what was the person name, where did he modify it from, did he modify it from his local laptop, office network, all of those things. You need to be able to monitor those, because whenever, I mean, you're working on a critical data, you need to have those visibility. Again, as we talked about the replication tiering, there are like the life cycles, different storage classes, tiering. There's another one which is called as cross region replication. So if you have a data in uh, maybe Europe, worst case, if something happens in Europe region, maybe some natural calamities happen, and if those data are very, very critical, you can replicate that data maybe in India or maybe US in some other region. So yeah, you can do all those uh, cross region replication if there is very critical data uh, available. Now, events. Simple example will be, there is a bank, every night lot of transaction happens, and they want to have a report. And once the report is generated, they may be uploading it to any of the cloud provider storage services. Now they want to review that particular documentation or those transaction that has happened on the entire night. So all these things happen, you can do it on the fly using event notification. So example will be, whenever somebody uploads a file into an S3 bucket, you can run certain actions on that. So automatically under the hood, you can create a function that can review those particular documentation and send out an email or something of those sort. If anybody uploads a file or modifies a file, and if you want a notification, yeah, you can do that. So any modification or things that can happen on the data, you can have an event that can trigger to do certain actions like sending an SMS, email, modifying the data, again something of those sort, you can do that. Now, another piece of the data is databases. Again, you might have heard it during your curriculum. There are like relational databases, non-relational databases. So what are all these databases? Again, in very simple term, the word relational databases means there is a relation between the database. Example will be yourself. You have a age, you have a height, you have your college name, you have your degree when you are born. So it's a relation. So with my name, I have a relation with all of this particular data. So those kind of data is called as a relational database. So, and most of this database examples. Another example will be like Excel sheet. Most of the Excel sheet, there is a relation between each columns or row. So consider relational database. How does it look like on the database? It like is again very similar to the Excel sheet. So yeah, something of those sort. Again, technical word is like it's a structured data. There is a clear structure between the rows and the column, which is called as a schema. There is a multi-user support, so which means multiple people can access the same application consistently. So because there is no modification to the data, you can consistently access it. Again, scalability is very easy. Again, if you have used Excel sheet, if you like to dump thousands and thousands of lines of data, you can easily do that because it can easily scale. Again, there is a clear relation. Sometimes it get become complex if certain, sometimes there is field missings, especially when dealing with large data. So scalability is easy, but it's also challenges because there is a one-on-one relation between the data. Again, so use cases are like including e-commerce. We just talked about ourself, our age, and all those things. Financial transactions also has certain relation between each, like time, the amount, is it a debit or is it a credit transaction? So all of those is a relation. So the next one is no relational database. So again, consider an example. uh, After this particular session, you will be asked to do the survey. Sometimes you will have yes, no, good, bad, all of those things. It might not be a relational database. It is more of called like a key value pair. Sometimes there are like videos, photos, um, or like GIF. So those kind of databases are called like as an unstructured data. There's no real structure between different columns or different rows or different schemas. So that is called as a relational database. So advantages are, again, it's a flexible model. uh, as there is no data, you can have anything in it. Another example is like a graph database. uh, Again, scalability, the most advantages about of the non-relational databases are the scalability, because there is no relation between each data. You can scale as much as you can. Again, use cases, as we talked about, are like social media platform, real-time analytics, sensor data storages, and another one that we discuss is the key value pair storage, like uh, the surveys that may happen on something of those sort. Yeah. Any questions so far?
No,
So
sir.
yeah, so the question I see right now on the chat is, sir, WhatsApp also uses cloud service. Which services they uses? Again, it's a very, WhatsApp is a service on the customer side, but on the back end, they might be using many different services. So maybe security of the user. So if you are two different friends, you are in the contact. So you are in their particular contact list. So they might be using some kind of user management where y- you can only see photos of the user only when those are in your contact list. So can backend services might differ because AWS has like 40,000 or 4,000 services. So different services might have different thing. Again, networking, they might be using a global networking where if I am in United States, I can chat with you over the global route. So yeah, I mean, it's very hard to say which services they might be using. Yeah. So the next pillar is the security pillar. Again, I won't go into user management, Linux management, and all. I just want to talk to you about the models. Again, you already are familiar about this, but technically, I'll just show you what is it. So, on the on-premises, how does the security looks like? So everything you have to manage. Now, when it comes to the hardware, compute, data, On the on-premises, it's what you manage. But on the cloud is where software networking, again, all the four pillars that we talked about, providing the storage, the databases, networking, compute, security is what AWS will provide. Also the hardware, like the virtual machine, different type of the virtual machine that we discussed, C type, M type, GPU type. On top of it is where you use the client side encryption, server side encryption, network traffic encryption. So those are all these services that AWS has on their side to offer you that. Client side encryption can be done using KMS key. Again, server side also has like a file system encryption. You can use KMS keys to encrypt your data. Yeah. And on the operating system is where you can use some kind of firewalls to configure IP table rules to configure on your systems to block, review on all of the. On the platform side is where the access management system comes in. So if somebody is a professor, he has certain access. If somebody is a student, he has certain accesses. So you create groups for those things. If somebody is a monitor or somebody is an HOD, he has certain privileges. So those kind of logic is what you need to think when you talk about the uh, security models. And of course, it's where the customer data is. So you revolve around all of those data thing. So now the word compliance and what are all this share responsibility model. So even though AWS says that this is my responsibility, but there are certain responsibilities which both you and AWS or the cloud provider both have to take. Again, on the bottom is where we just discussed region, global infrastructure, compute, storage, database, networking, hardware services. AWS will take care of those, like cooling system, connecting Ethernet cable, giving the internet, updating the servers. If there are new type of servers that come into the market, putting that into the rack, cleaning the whatever is that is AWS will take care. Now there is also a customer responsibility on top, which is the sky blue line. So you are responsible to create a management or the operation resiliency. You are responsible to watch your logs or your systems. So in case there is any failure, you need to know how to manage those failures. AWS won't do that for you. AWS has services that can do that, but it's your responsibility to create a management around those services so that you can manage your own service. Again, workload architecture. I will just show you one of the slide. What is it? And again, you need to
Sorry to
continuously.
interrupt you.
Yeah.
Sorry to interrupt you. Are you sharing any screen?
Yes. Are you?
No,
Is
I think
anybody not able to see my screen?
screen is not visible.
You are visible, sir.
Oh, sorry, then it should be my network. No, thank you. Sorry.
Okay. No problem. Yeah. So again, responsibility on the customer side is continuous testing of their critical infrastructure. Again, all this compute storage now, they have to make sure they are doing continuous testing of their own infrastructure, not the AWS infrastructure. So it's a share responsibility model again. So during the interview, whenever somebody talks about the security, if you don't know application security and blah blah blah, you can still talk about this, some of the core pillars or the thought process about this. uh, Again, now responsibility particularly in the security differs between services. When we talk about the uh, like virtual machines and stuff, so it's where it has a different responsibility. AWS will just take care of the hardware and the compute storage, but when it comes to the different services like um, Cassandra or databases, it's a platform or is an operating system. So AWS also take care of the operating systems on behalf of the customer. Now, when it comes to the storage services or the KMS keys, there are like different responsibility. Now, you don't need to take up care of this service side of encryption. AWS will take care of it. You need to take care of this service side of encryption. Again, during the interviews, make sure you have basic understanding of this share responsibility model. And yeah, share responsibility model changes when we talk about different components within the application or within the services. So again, very short slide on the last pillar. Again, if you are a guy who likes reading about generative AI and all of those stuff, so this is for them. So now everybody knows that you on the fly you can create any photos, videos, all of those things is called a generative AI. What is a generative AI? Again, as the word suggests, generative artificial intelligence, it can generate a content based on the experiences that he has. So whenever you close your eyes, if you imagine something just like how you can imagine or you can do similarly, all this software, large language model system, they have that particular capabilities to create stories, summarize, work for you, write an email for you. He has that particular imagination or that intelligence to create that content for you. So important generative AI stack is where you need to know. Right now you are only using chat GPT or all of those things as a user, but how under the hood it has been created, let me just show you about this stack. Again, it goes back to the foundation, infrastructure, training and inferences. It's on the bottom is where the actual crux of the hardwares are. There will be a GPU, there will be elastic fabric adapter, there will be C2 capacity. So again, all this hardware is where is present on the bottom. On the top is where you do the foundational model training and inferences. You can use different services. One of the AWS services called as AWS Bedrock, where you can get the any model that are out there. You can actually use that model for your uh, model building. And not just that, another example, again, the capabilities of all of this thing is like you are trying to maybe access your university data. Example will be you have roll number, age and everything. Is it a male, female data, and you are doing certain reporting on like whether or not it is pass, fail, all of those things. So some of this important when you are working on those, you don't want user to have information about the age or what caste it belongs. So you can create guardrails around those data. Like, I don't want anybody to uh, see my phone number or my email addresses. So you can create an actual guardrail around the data. So that's where all these services that comes in on the AWS. So if you are trying to build something, so you need to make sure that you have guardrails around those data. Yeah. So again, bottom is where the hardware. There are services like Bedrock which can provide you the guardrail, the agents, and the models. And on top of it, there are like tools that you can build. And the last thing is the application layer is where, uh, again, you might not be familiar with all of these services, but just consider uh, Chat GPT or something of those, like where you actually interact with the bottom part. So it's a UI or it's a application where you can communicate to the Bedrock services or the agents. Yeah. Again, it can get really complex. I don't want to go into this. Like, again, you might have heard, oh, this model took like 30 days for the training and all of those. So how does that happen? So are we saying that it just happens on one single EC2 instances? No. Or on one virtual machine? No, there are like thousands and thousands of machines. So how do you connect with those machines? So these are all the logics that goes into like how do you connect each virtual machines with GPUs with each other. So in case something goes down, so auto scaling group will come in, he will create another instances. There are health checks agent that performs the health checks of the instances. So again, a lot of things get goes in. There are like frameworks around that as well, like distributed model. So there will be a small part of the model that each machine will start processing while doing the training. So that way there will be a parallelly many different servers are doing the same processing, thus it will be a faster, it will be resilient. Like if one machine goes down, it is still okay because I have 1,000 different services that are processing it for me. So again, those logics that goes into picture, but again, at the high level is what this the AI stacks will look like. Again, how do I use the foundation model um, on AWS? So one of the services called as a Bedrock. Again, it's a very simple interface where um, there are already a foundational model created by AWS and also by different providers. If you would like to use that, there is an API through the Bedrock. You can use the founder, but you can create a prompt, talk to the API, and API will forward the request to the backend model, and that's how you can do. And again, if you would like to do fine tuning, you can do the fine tuning of those models. And on the right hand side is what the AWS SageMaker will look like. Again, if you are building a model or training it, so on the right hand side is what you will look like. So there will be hardware on the bottom where you need to choose. There will be a foundational model that you have to choose to train and inference. so, so again, depending on how to access it, there are different ways how you can access it. Yeah. So again, we talked about 4 pillars, which is very important. One of the new pillar is the Gen AI, but you can even get more innovated with the AWS. There are different Internet of Things like IoTs. Again, if you are an hardware guy, you like to uh, learn about the sensors, like so IoTs is another pillars that you can learn. Machine learning, blockchains, again, how this financial transaction happens, satellite communication, space communication, AWS wavelength, like cellular, how does all this wavelength communication happen? So you can get as innovation as you can. There are different services that AWS provide, again, not just AWS in general, but foundation is what we discussed today: compute, storage, networking, and security. You need to have basic understanding of all of this thing. Even on top of it is the Linux system and the basic of networking knowledge. You need to for sure have that knowledge. Now, I just want to talk about, again, this is more of the interviews kind of question, or as an engineer, how you should be talking about when you talk about any tools or any software. So AWS say that it's a where architecture framework. So there are like 6 different pillars: operation excellency, security, reliability, performance, cost, and sustainability. So usually I remember it with like CROPS, CROPS, C for cost, R for reliability, O for operations, P for performance, S for security and sustainability. Anyways, so what is this pillars? So whenever we talk about any application, any tools that you would like to use, any testing that you would like to do, you need to technically talk about these pillars, like operation excellency. Am I running my application operationally correct? If yes, how can I check that? Is my application completely secure? If yes, how can I make sure it is for sure using the best practices that are available out in the world, that what security experts have recommended? Is my services reliable? Is my services performance efficiency? What if I want to do cost optimization? What are all the different ways I can do it? Is my services, so these are all the frameworks or the pillars that you can whenever you talk about the tools or your own application or during the interview, you need to bring this up so that they know that you just don't know how to create a simple Python functions, but you can also talk about the security behind it. How is it reliable? What if I accidentally inject a failure, like in the prompt? If will my function be failed? No. So that's when technically how with all these pillars, you will be able to speak more technically. I mean, when speaking with some of the technical experts. I had a link. Let me just. Not sure, I'm not able to type. Interesting. I'm not able to type on the browser. Yeah. Okay. So these are the 6 pillars that we just talked about. So again, as a college project, maybe professor can just create 6 different group and everybody can talk about operation excellency. What is it? Each group can explain. So again, I really like when somebody understands the basic pillars of the architectures. This is nothing to do with your electrical engineering, software engineering, anything. So in general, you need to understand what these main pillars are, so that whenever you talk about the performance also of your models or on your Python scripts and all. So yeah, I mean, that was just an illustration, like simple function of Python. Um, it was just an illustration. If you are writing a simple Python which does 1 plus 1 or like a plus b, yeah, it's a simple function. But when you start talking about all these 6 pillars, like, hey, interviewer, I have created a security within my Python. What if somebody accidentally put like 50,000 characters in my Python function to do 2 pluses? So my function will break. So I have this security thing within my, like, if somebody accidentally types some incorrect thing, it will fail. So some of those things is what I'm just saying. So if you have a simple Python function to explain that function, you can talk about the 6 different pillars. Yeah, let's go back. So again, I've just kept a screenshot. You can have this as a reference. Okay, so I just have a couple of more slides. Yeah, as we see, I mean, as we know what is the cloud computing, and so these are some of the advantages. Is like trade upfront. So again, you don't have to buy new servers when you're doing some kind of testing. You can use the AWS services or any cloud provider services to do your testing and stuff. Benefit for massive economic of scale. So if you have planned to scale out, you can immediately scale out during the night, during the day, or during an hour. You don't need to wait to buy the servers, come back, put it in your rack. No. Again, stop guessing the capacity. AWS is a global infrastructure, so they have a lot of space, storage available, so you don't need to worry about the capacity. Again, if on the left hand side, if all of this thing is present, you will immediately be able to speed up your deployment or speed up your businesses. And another thing is, like, you don't need to spend maintaining all of those things on your end, because you need to hire network engineers, storage engineers, um, space to put those things in your house or in your offices. So you don't need to do that. Again, you can go global in minutes. So if you don't ever know, if you have an application that you build and everybody likes it and you want to really spend it across the world, you can go do that in minutes, because all this cloud provider, they have services or global infrastructure. You can scale out immediately. Again, I've just kept this last slide as a characteristic of cloud computing. Again, when we talk about all of these things, you can see, I mean, you can use those technical terms like, okay, this is an agility. So you can rapidly, inexpensively scale the infrastructure resources. You can access the resources or the software using APIs. Cost is one of the factor where you can reduce. Again, these are some of the characteristics that I have just listed down. Multi-tenancy, which can help you share resources across teams or across organization. It has reliability, you can scale. There is a security we talked about. Again, maintenance is like there is a shared responsibility. Some of them customer need to maintain, some of them AWS need to maintain. Again, metering is the most important. So you only pay for the services that you use for minute, for hour, or for days. You don't pay for anything that you don't use it. So that's the most a good part about cloud computing. Yeah. So that was the last slide. That's all I had for today. Again, I will repeat the main PPO. So purpose, process, and outcome of this was not to teach you any AWS services or any cloud services. It was just to show you some of the roadmaps into cloud journey. So it's okay if you don't understand any of this, but at least you should be able to understand the slide that I had. Like cloud is all about different pillars: networking, compute, storage, security. Take any of this pillar and start learning. You don't need to know the entire cloud from top to the bottom. You can be a master in one and then average on another one. So this is the, if you go home, this is the main slide that I want you to take home. Like cloud is nothing but 5 different pillars: networking, compute, storage, and security. One of the new things that recently everybody is talking about is the Gen AI services. Yeah, that's all I had.
Thank you so much, sir, for your valuable and informative session. If anyone has questions, you may kindly unmute and ask or drop your questions in the chat box.
Again, you can be friends on LinkedIn if in case anybody would like to connect. That's my LinkedIn profile. So how is the scalability handled on the backend cloud? Again, a very good question. So the word scale, right? The scaling means you add multiple resources, and that's how the the application scales. So you can add virtual machines onto your application. Like right now you only have one virtual machine. If you require 2 different virtual machines, AWS has a lot of space available that you can use it or to launch the virtual machine. So that's how you can scale. So another one is I'm doing a research on the LLM model for a domain specific chatbot. Once I finish the work, how can I integrate it and provide it to the people like Jeff? Again, so this is where the power of the bedrock or this cloud services comes in. So right now you are working on a large language model, which means you are designing a model or you are fine tuning those models. So once those, I mean, to even do the fine tuning model, you can use SageMaker Hyperpods or SageMaker AI Studio, where consider an example, you have thousands of petabyte of data. Where do you store those data for your training model? You need some kind of S3 bucket where you can store. So all these AI studios, you can integrate that with the data store, fine tune your model. Once that model is ready, that's when you can publish it in the SageMaker endpoints or in the Bedrock. Bedrock has a capability to create the endpoints. Endpoints are nothing but like a URL where you can actually access the model. And even if you would like to, if you are still testing it, you can even keep it private. That way you can only access it by yourself. And with just one single button, you can create it public. And again, a good part about all of this thing is, even though that model is out there, if nobody is using, you don't pay for any of those things. As long as you start using the CPU whenever anybody requests on your chat, that's when you pay. But again, very good question on like how to put LLM into that's is actually my job at AWS. So I work with the startup Gen AI companies. They are very sharp as designing, creating the models, but sometimes they struggle on how to put that in front of the customer. That's where I come in to suggest them, oh, use this GPU instance type, use this type of particular service. This is the architecture. Now they start asking me questions. Oh, is this architecture secured? So that's where I bring in all this well architecture framework. So even before they ask me any question, so I make sure whether or not the design or the services that I have used is does this support all of these 6 pillars or not. So yeah. uh, if I work in the AWS, then how can I survive in their surrounding? I did not got understood the question. So the next question is fine tuning always better than training a model? Again, depend. Example, if you are designing a, a model where maybe for Myntra, like example, you come in front of the camera and automatically based on their inventory, if you chose I need a white shirt, blue shirt, black pant, whatever, and in front, if you come in front of the camera, automatically it will just take the face and then put the remove put the new clothes that they have in the inventory, and you can keep swiping. So if you have seen the lens cart website as well, so if you're designing that and if there is no model out there, then yeah, it will make sense to create the model from scratch. But if there is any models that are already out there which you can use it for your use, then yeah, you can use it. Again, I did not follow that particular circation. If you want, you can just come on unmute and ask question. So the next question for testing purpose, how can I config my PC as cloud service? Whether, yeah, uh, if you see local stack, again, this is also for the professors. Again, if each student cannot afford a cloud price, which is of course very high, probably maybe you can buy a server and deploy this local stack. It's nothing but a Docker container. Whatever you see it on the browser, like whatever I was showing, you can actually see that via the local stack. So S3 and everything. So you can deploy the local stack on your own local machine and you can create a cloud. So yeah, this is the local stack. Yeah, for testing, how can I configure my PC as a cloud services? Yeah, so local stack. How does the AWS plays a major role in real-time application? Again, AWS is a service. Like consider example Geo. So Geo doesn't play any important role in real-time application or AWS. You have to design for the real-time application. So how do you design for your real-time application is where the architecture will come in, like what kind of services you would use. So again, real-time application might require very fast hard drives. So what are all the hard drives that are available which are very fast? What are all the network adapters that are available very fast for the network to be very fast? So that's where again I said like network and system will come into very critical, because if you understand the basic crux of the system and the network, you should be able to choose services because you have the foundation. Again, real-time applications, um, there are different type of load balancers where you don't need to where the application load balancer won't process the request, it will directly go to your application. So again, there are different architecture how you design real-time application, but how AWS plays a major role is like they offer a lot of different services, uh, which you can use it to build real-time application. I am a mathematics students, and today I learn about clouds and their pillars through. Yeah, okay, thank you. In your workplace, how in the workplace, how can survive, sir? Uh, See, I mean, most of you might be in 20s. You have just started understanding what is engineering. So talking about the survival, I don't see that is a concept. You study well, you eat well, you play well, you do everything. You don't need to worry about the results, is what I feel. As long as you keep learning every day, maybe 15, 20, 30 minutes. I don't even say learn, study for an hour. Just learn it for 15, 20 minutes, but no phone, nothing. Just learn new things. Follow some of the good people that you like. Like if you, again, if you would like to become a cricketer, then follow Sachin, Yura, whoever they are, like, or your role model in that particular field. If you would like to become a software engineer, follow some of the software engineers, what they do, what kind of thinking that, and try to understand their routine, and then see if you also like their approach. And during those research, you will find that, oh, I found a new tool, I can use this. So that's how you survive. So you survival is all about like learning new things. So even today I've been working with AWS. I joined as a very fresher, straight out of college. I had to learn a lot of things. If you see 6 different pillars, it's very difficult when you haven't seen any of these AWS services. Second thing is about the communication, because we are not a native English speaker. It is sometimes very difficult to speak, communicate in English. But again, slowly, steadily, if you are in that particular path, it is a slow path. Again, I was talking to you, one of your faculty, I think so, Dinesh sir. It's a long journey, or your HOD. 1 hour session is not going to change anything. It's a long journey. It is like a year work where every students have to contribute for each of your development. Like you cannot learn sustainability, reliability, performance. So small projects, you need to watch somebody, see how they think, how they came up to a point, ask multiple questions to your fellow engineers. They will ask you follow-up questions. So that's how you learn and survive in this particular era. So what is the purpose and opportunity over research in companies? Again, I honestly not from the research background, so I don't want to say it is bad, good. But again, engineers, we are a problem solver. As long as you have a problem to solve, I think so you will be relevant. If you are just doing a research, research that doesn't solve any problem, then that is where the challenge will come. So if you are a research student, you should exactly know what is the problem that you are solving using your research, so that you can go talk about it in front of whoever you would like to. So I want to create a cloud services. Again, you need to focus on this 4 pillar, take one of the pillar and keep learning the other pillars. There are like free courses, not free courses, but Udemy courses available where you can learn about the AWS cloud computing architecture and all of those things. So if you are getting started, learn about the foundations that we talked, Linux systems and the networking, and then go into the AWS cloud. Again, Windows or Linux is suitable, again depending on you. My experience is 80% of the people use Linux in the actual companies. If you are again a Windows user, I'm not saying people don't use it, but there are like very few people that use it because of the licensing issues and stuff. So if you are today developing a software, you don't want to buy a Windows license to sell to your customer. So you will design it on Linux so that Linux is free. You can easily scale or sell it to somebody. Again, opportunity wise, again, this is a end question. Again, if you go on an amazon.com or any myntra.com, if you like the color, if you like the quality, if you like it, then only you will buy it. Similarly goes with the person. If you have a knowledge or a quality that the other person likes it, then only you will be hired. So again, during the interview, if you get rejections, it doesn't matter, because probably he needs something that you don't have, and vice versa. Like, you don't know something that he really wanted to know. So maybe for that particular project he needed somebody with special gen AI experience. You are good with everything, but maybe it's not about you don't know, it's just about knowing what you don't know and just working on it. Can you please share? I mean, I have shared the email addresses, LinkedIn. Feel free to, I mean, chat, but email and contact, I may not be replying, because again, right now I'm working with you for like 1.5 hours or 2 hours. So yeah, LinkedIn is a preferred method for me. So yeah, somebody was speaking. Kalyan
Good
was speaking.
evening, sir.
Yeah.
I am Amrita Manigandan from Ramco Institute of Technology. I'm studying computer science and business system. I would like to ask a question. Can I ask, sir?
Yes, yes, yes. Go on.
How does cross-region S3 replication ensure data consistency, sir?
So again, very good question. So AWS has eventual inconsistency. So like an example, if you store a data in a region which is US region, and if you're doing a data replication, AWS will use his edge location or the pop location to replicate the data through the Amazon Internet Network into the other region, so that the data inconsistency is like consistently in different region. He keeps a copy of your data, and that's how it replicates, and the data consistency is better. But again, it's an eventual inconsistency. So immediately if you write something in US region, that data won't be available in Singapore or in India. You need to wait until that data has been replicated through the network, through the pop location or the edge location on the other regions. Does that answers your question?
Yes, sir. Thank you, sir. And I have also another question. Shall I ask?
Yeah, yeah, go on.
How AWS is better than Google Cloud, sir?
Again, this is not a comparison. Each cloud provider has different advantages. The main advantages I personally feel, again, I'm not saying on any company behalf or anything. Was one of the very initial company that started the cloud journey. So adoption wise, many people started using them. So again, if you are an Android user, it's very difficult to move to Apple, or maybe vice versa. If you started liking something, it's very difficult to move, right? So similarly, in the cloud services, as people started using AWS cloud, Amazon got a lot of feedback. They improved, so their services got little stable, like much stable. In other words, as it got much stable, a lot of other people also started using. So it got a cascading effect. Like that's why AWS has the majority share market in the cloud provider. So again, I won't say Google is better or AWS is better. I will just say they all are cloud providers, whichever gives you the best services. Like I mean, as a company or as a business, you should use that. If they provide some cheap storage solution with excellent resiliency and security, and maybe if you feel like AWS is not able to give that, so yeah, I mean, you should use Google. And again, vice versa, if the AWS has the latest generation EC2 instances that they have offerings, and yeah, you can use them as well.
Thank you, sir.
Yeah. Okay, so um any other question? If not, then I will just stop, and then
Good
we'll
evening.
give back. Yeah,
Hello, sir.
yeah, go on.
Sir, good evening.
Yeah,
In this industry, AI is going to boom. What is the future of coding and other things in IT in the result of AI?
so again, I mean, this again falls back to like from we moved from bicycles to car, I mean bike, and then bike to cars, and then metros, trains. So again, it's an evolution. nobody imagine, oh, what will happen to my bicycles when during the old age. So as the life evolves or the industry evolves, you need certain things to do certain stuff, because everybody is now using phones and websites, and there is a huge amount of data. Engineers or a single person cannot manage that much of data. That's why all this generative AI that came in, because it has a lot of data history that he can read, understand, get intelligent and work on it. So now going back to the question, how gen AI is going to be useful or not useful for the developer, again you have to start using them in your day-to-day life and improve whatever skills that you are doing. Like if you are a Python developer, Java developer, you use those particular service to enhance your coding. Like again, we talked about 6 different pillars. Coding might also have some where architecture framework. So make sure your code is such built in such a way, or as a software developer is such a build way that it covers all these pillars, and you can take help of all these AI tools to achieve those things. So I will just put that in that way.
So, may I ask you a question?
Yes.
How should I design a multi-AZ architecture for high availability, sir?
Um, let's see if I have it. Again, so it's very simple. So if you see, multi AZ architecture means you are deploying your virtual machines in different availability zones. And as simple as that, you create 2 different virtual machines in different availability zones. So one in 1A, one in 1B. They are again completely different geographical location. And then you put one load balancer in front of them, which can load balance the traffic across different availability zone. In short, different EC2 instances. So if this instance on the left goes down due to some natural calamities, your customers or your users can still access the traffic using the right instance. And if both of these goes down, which is again very rare, you can also do a DR. Like you can have this architecture in completely in a different region, like in Europe region. So if something happens here, you can always point the URL to the Europe region. So that's how you create a fault tolerance or multi-AZ architecture. So again, I mean, we are almost on time. I will just move the mic back to the faculty member. So can you take over? Again, thank you all for.
Okay, sir. Thank you.
Thank you.
Thank you, sir. Thank you very much.
Thank you, sir. Thank you. Nice presentation.
Thank you, sir.
I invite Mr. Pondaran Kumar from second year CSBS to deliver the vote of thanks.
Good evening, everyone. On behalf of the Department of Computer Science and Business Systems and RIT Stitch Students chapter, I take this opportunity to express my heartfelt gratitude to our speakers, Mr. Diswell Dubaria, Cloud Computing Engineering at Amazon Web Service USC. Your session on enhanced cloud and visualization for the future innovators was truly insightful. You clearly explained how cloud technology drives scalability and security and innovation in today's digital world. The real world examples you shared helped us to understand how visualization simplifies complex systems and improves the performance. It was an eye-opening and inspiring section for all us. Thank you. I also thanks our principal, Dr. L. Ganeshan, and vice principal, Dr. S. Raja Karnakaran, and head of the department, Dr. M. Komudinayagam, for the constant support and encouragement. Special thanks to our faculties and the student coordinators for their excellent organization, and all participants for active involvements. Thank you all for making the event a great success. I have a wonderful evening ahead.
Thank you, Pondaran Kumar. With this, we conclude our webinar. Thank you everyone for joining.